Hello, everybody.
Hello. Thanks. So, welcome to Hacking Your Favorite Kiosk. This is Aristotelis. He is a penetration tester at 12sec. He plays guitar and he also sings. You can find him on LinkedIn. Yeah, we know, he's a boomer. He doesn't have Twitter. That's why we bully him. And that's all.
This guy is George. He also plays guitar. We had a band also that we can play together. He's also a penetration tester at 12sec. And he's not a boomer because he has Twitter.
Okay. Moving on with the most important question of the presentation. What is a kiosk? This is a kiosk. Moving on. How to attack a kiosk? Okay, this is how to attack a kiosk. Moving on. And now let's talk about how to hack a kiosk. Or maybe one more way to hack a kiosk.
Test. Let's discuss a little bit more what a kiosk is. What do we mean in this presentation, kiosk? Kiosks can be found in various locations, including coffee shops, restaurants, libraries, etc. They are Windows or Android machines. The basic detail they have is that they are in an isolated sandbox environment which locks a specific application. It doesn't allow users like public users like you and me to interact with the basic operating system of the device, but only with a specific application or applications. Yes. Another thing about kiosk is that. Sorry for my.
We had a project of 12sec that was around the kiosk pen test.
Yes,
so we started researching on the topic and trying to figure out what to do. So we started with the simple Google search on what a kiosk device is.
Yes, as you can see, the first thing that came up was a feature that Windows have called Kiosk mode. We did a little bit more research about our project, and we see that it's likely to meet a Windows operating system, a kiosk device with Windows operating system. So we started our preparation. We first we set up a virtual Windows lab. We used the kiosk mode that Windows have, and also a tool called Front Face Lockdown tool that locked for us the Microsoft Edge web browser. Basically, what we did was set up a simulation of Kiosk, which was internet web browsed Kiosk, if we want, with a keyboard to write comments or Google, and a mouse to navigate through the system. And then we try to escape from this isolated environment. Okay, this is just a video how did we manage to attack this. This attack worked for us on this specific example I gave you, on this specific simulation of Kiosk that we made. Basically what we did, I'm going to explain it now from the start. We have in a Kiosk mode a website, our website. By pressing F1, we redirect ourselves in Microsoft Edge homepage. From there, we tried to download the file. So the file explorer would pop up. And from them, we just call the CMD prompt. And that's it. We escape the lockdown environment and we have access to the Windows operating system. Okay, the next thing that we did was to arm our tools, to prepare our Rapid Ducky and Bus Bunny USBs and Flipper Zero, and to write code, basically to have an attack, a physical attack, in case we have USB ports exposed on the machine. For those of you who never heard bad USBs are emulate an input, a human input device, like a keyboard or a mouse. When you plug into a computer a bad USB, automatically sends keystrokes to the device, and eventually will download or execute malware, among other nice stuff. Anyway, I won't analyze it further because we didn't use them actually so much. If you will see later on that we didn't use them so much. Just think evil when you hear bad USBs. Okay, so also made a bootable USB with Kali Linux operating system. Just to mount the hard drive. The next thing, we grabbed these USBs, we grabbed our Flipper Zero, we grabbed the USB cable, an Ethernet cable, and we put it all together in a big bag. Yes, like that. Okay, to be honest, the bag wasn't so big. There were small things. Anyway, we were ready and we were off to go to the client. George, are you going to help me with this presentation? Because,
So, we headed to the client. And then we were wondering what to do. So we created a small checklist to help us go through the engagement. We should answer all these three questions. Which OS is running? Are there any exposed physical ports? Do we have power supply access? So we started by trying to answer the first question. Yes, we had access to physical ports. Yes, we have access to power supply. We could unplug and plug in the device. And so we thought, what's the easiest way to check which operating system runs behind the device? Simply by rebooting it. So we unplugged it and plugged it back in, and then it automatically rebooted, and we saw that it was an Android system. Okay, now what? To organize our thoughts, we categorize our attacks on what we can do, what's our attack surface on a mobile device, on a Kiosk mobile device. So, we categorize them at application level attacks, OS level attacks, and hardware level attacks. When we're talking about application level attacks, we mean about all the mobile app attack surface that you should have on a mobile app penetration test. And also in the scope is crashing the application, because this would help us to exit the isolated environment. And yeah, that. This same will crash. And finally, we can use protocol handlers to escape a browser maybe. If we have like access to a browser and then we could input a link. The link would be like mail to, telnet, and then this would maybe help us to exit. By the way, this is a great tool made by a very cool guy called Paul Gregg. He made a presentation at DEFCON about this. You can check this out. This is really cool. Okay, about operating system level attacks. Do we have an isolated environment? Is there any application that maybe isolates another app? What happens? Are the gestures enabled? Can we swipe down with 3 fingers and maybe exit or minimize the application? Are the keyboard shortcuts enabled? If you don't already know, if you plug a physical keyboard inside an Android and in an Android environment, you can navigate from there too. So if you press the home button on your keyboard, you can just minimize an application. What's the reboot behavior? Does the device automatically opens the isolated environment? Does someone need to manually open it using a pin or something? And pin brute forcing is, when we say pin brute forcing, we mean that basically most of the Kiosk isolated devices have a pin that allows the developers to exit from it. So, in most of the cases, the pin is 4 digits code, so you can just force it and exit the application the intended way. And finally, hardware level attacks. We have secure locks in place that restrict access from physical ports, like USBs, etc. Do we have exposed physical ports? And finally, is the power supply exposed? Yeah. And now let's talk about how did we escape. We escaped with all the previous techniques mentioned. So let's summarize them. We made the application crash using various ways. One of them was it was an ordering system where you could write a comment on your food to specify I don't know so much ketchup or something. And then if you wrote a very huge comment, the application couldn't handle it, and then when you tried to send it, it crashed. So that allowed us to escape. We could also escape through Android's built-in keyboard features, because you already know that in your Google keyboard you have some buttons, so you can just go to the settings from there. We could do that too. Gestures were enabled to do. We had physical access to physical ports, so we could just plug in our keyboard and press the home button on our keyboard, and then the application just exited. And also, the very weird thing was that when you rebooted the device, it didn't automatically open the isolated environment, and someone needed to come to open it, and then restrict the access. And finally, the pin brute forcing, as mentioned before, the intended way for them to exit the isolated application was by pressing 5 times at the bottom right corner. So if you pressed 5 times at the bottom right corner, a small menu would pop up that asked you for a pin, and the pin was actually 1. It was not 4 digits. It was just 1. Yeah.
Thank you.
And let's move on to the post-exploitation, Aristos.
Okay. Now we're in. Okay, we have an Android operating system, and we're in. Let's take a breath to do our post-exploitation attacks. The most important, root the device. To do that, there are some steps that we are going to follow. The steps are, first, you must enable USB debugging. All the Android devices by default have disabled USB debugging. You know there is a trick, I don't know if you know it, but you can press the build number and open a hidden menu that's called developers options. And from there, anyway, you can enable USB debugging. That's what we did. We enabled USB debugging in order to connect our attacking device, with the Android. The next step is to enable OM unlock. This is a feature, actually, that the manufacturer made for us, for every public user. So, in order to avoid the simple user destroying the device, messing up the device. So they made this feature. Actually locks the bootloader. That's important. Anyway, we also, you can see in the left screenshot that we managed to enable OEM unlock to basically unlock the bootloader of the device. And the next step was to reboot the device into safe mode. This happened because we would disable the bootloader. So in the right screenshot, you can see the device in safe mode. From there, it was very easy because the Android operating system that we have was outdated. So by simply using the Kingo Root application, we managed to have root access. Okay, let's go to the second post-exploitation attack, persistence. It's important also. Persistence through ADB. ADB is also debugging, like USB debugging, but you can do it wireless also, through the network without a cable, a USB cable. Also, you can mark your attacking PC, your attacking US device, as a safe device. And you can connect to the victim device, to the Android device, without credentials, just by hitting the device. So you can use that for persistence also through network, etc. Persistence through malicious APK. This is the way that we did it was with a simple APK that we made using MSF Venom. You can see a simple command. We made a malicious reverse shell actually APK, and as you can see, we got shell like that. You can also have the application running forever. You can lock the application to run every time the machine boots. You can do a lot of stuff and have persistence forever. Okay. Street credits exploit Kiosk nearby devices which are connected to the same network using the Kiosk. Okay, countermeasures. Can you help me with that? Thank you.
Let's talk about countermeasures. How can we avoid our Kiosk getting hacked? Things are simple. We should start with secure coding practices, sanitizing our input, for example. We should have a stable application, an updated environment, and use a proper Kiosk application that helps us isolate our environment so anyone cannot exit at the operating system context. We should not expose physical ports like USB ports, buttons, and stuff like that. And we should also do not have access to the power supply. I think that's all. Yeah, these are the references that we talked about in the presentation. You can have the PowerPoint later, so you can have them. And that was for us. Do you have any questions?